Next topic is the synthesis of aldehydes and ketones. Every one of these reactions is something you've already seen, so nothing here is new. So if you want to synthesize an aldehyde, the trick was to use either PCC or the pyridinane. This is from the previous chapter. Remember, with the PCC or the pyridinane, it stops at the aldehyde. If you want a ketone, this case you can use, you got to start with the alcohol. If you want a ketone, you can use any of them. PCC, pyridinane, CrO3 an acid, Na2Cr2O7 an acid. Any one of these four is fine. Stops at the ketone. Remember, up above with the primary alcohol, if you added the CrO3 or the Na2Cr2O7, you get the carboxylic acid. So remember, it completely oxidizes. The other method we've learned is by taking a triple bond, adding the mercury 2+ ion. I think we used mercury sulfate, and water. You form that enol, which then forms the ketone. We've also learned a special case of how to make ketones on benzene rings. You add the acid chloride plus benzene and aluminum trichloride, and you can make a ketone on an aromatic ring. The other way we've learned a lot of ways, is oxidative cleavage. So this is only how to make ketones. Use KMnO4 and acid, and you can cleave the double bond. Remember, we learned that. And if you have a symmetrical double bond, you form two equivalents of the same ketone, or you can make two different ketones depending on what the groups are. 9.4 is basically one reaction. It's an oxidation, I guess I should say, of aldehydes. You can't oxidize a ketone anymore. Ketones are the highest oxidizer you can form, but aldehydes, you can oxidize one more step. So let me redraw this. I was actually thinking about the product you form before I did it. Take an aldehyde, and you can either add CrO3 and acid, or this is something I just talked about last section, but just to kind of write it down again. So either CrO3 and acid or Na2Cr2O7 and acid can give you the carboxylic acid. So you can either start from the alcohol in this step if you wanted to, the primary alcohol, or you can start with the aldehyde. It doesn't really matter. Both of them will oxidize. In your book, they go over some other methods of oxidation of aldehydes. You don't have to know those. I'm not going to go over them. One of them uses oxygen. Another one uses a silver compound. We're not going to go over any of those. This is basically all that you need to know. 9.5 is going to we're now going to talk about the reactions that you can do with aldehydes and ketones, and they are nucleophilic additions. So let me give you a generic reaction. And like I said at the beginning, you can use ketones or aldehydes. Okay, see how I kind of write this little H underneath this R right here? That implies that can either be an R or it can be an H. So it can either be a ketone or it can be an aldehyde. Every reaction we do, it can either be a ketone or it can be an aldehyde. So I might just give you one example, but that means that you can do it with anything, aldehydes or ketones. So if you add some sort of nucleophile, it's going to come in, attack your carbon on the carbonyl, kick up the pi bond from the oxygen. So this is just a very generic mechanism to get your nucleophile added on there. And then you'll always have a second step. And the second step is adding acid, which basically protonates your O negative. And you've added your nucleophile. Now, what kind of nucleophiles can we add? Well, one is hydride. We've seen this last chapter when we do a reduction. And the reagents were either sodium borohydride or LAH, lithium aluminum hydride. Remember, LAH is the shorthand for that. I'm going to be using LAH from now on. Other ones are water. You can add water as a nucleophile. Grignards. I'm going to talk now a lot about Grignards. Grignards are carbon negative. and it basically has a magnesium as the counter ion. Let me just do a generic one where they have MgX as the counter ion. These form carbon-carbon bonds. These are holy grail reactions. It's like the acetylide reaction, which technically we can also have an acetylide as well. We've learned about acetylides that has the triple bond negative. These are also very good nucleophiles, but these act in the same way. You're forming carbon-carbon bonds. Remember I said that's like the holy grail of reactions. So we're going to talk quite a bit about Grignards in this chapter. That's really the big reaction that we're going to talk about. Other ones are cyanides. You can add cyanides to carbonyls. Pretty much anything with a negative charge you can add to a carbonyl.